Let us see this problem. We are given an n cross n matrix and we wish to rotate this matrix by 90 degree and we need to rotate it anti-clockwise. In this example, this is our matrix and if we rotate it 90 degree anti-clockwise, this will become the column. 1, 2, 3 will become 3, 2, 1. 4, 5, 6 will become 6, 5, 4. 7, 8, 9 will become 9, 8, 7. Right? So that's how we get the result matrix. Now if we see this example, we again rotate this matrix 90 degree counterclockwise. So we'll have 4, 3, 2, 1, then 8, 7, 6, 5, then this column, then this column. Now please pause this video and try to think of a program that takes a matrix as input and rotates this matrix 90 degree counterclockwise. Let us first talk about the naive solution. Time complexity required by this naive solution is theta n square and auxiliary space required is theta n square. The idea of this last solution is based on this fact. This last column becomes the first row. 4, 8, 12, 16, they become the first row. Second last column becomes the second row. Third last column becomes the third row. First column becomes the last row. So we have an idea now. Now please pause this video and try to implement this naive algorithm. Let's now see the implementation. I have written pseudo code here. This code is close to C++ and Java codes. In this implementation, we first create a temporary array of size n cross n. Now it traverses through the original matrix, and for every element of this matrix at index ij, we copy it at index n minus j minus 1 I. The idea simply follows what is written here. The last column elements should become the first row. These elements become the first row. And they follow the same order. 4 comes here, then 8, then 12, then 16. 4, 8, then 12, then 16. Top to bottom, left to right. So if j is n minus 1, it means you are in the last column. Then which row number should be in the output in the temporary array? It should be row 0, right? So if you put j equal to n minus 1, you will get 0 here. If you put j equal to n minus 2 here, it means second column. Which row number you will get? You will get the index of row as 1, which is second row. So that's how this solution ensures your appropriate column number goes to the appropriate row number. Let's now talk about the time complexity of the solution. It simply has 2 loops here, so n square, theta n square, then 2 loops here again, theta n square. So the overall time complexity is theta n square. Auxiliary space, it requires an auxiliary array of size n cross n. So it requires theta n square auxiliary space as well. Now please pause this video and think of an approach that works in theta n square time but requires theta 1 auxiliary space. So your approach should be doing rotation in place without using an auxiliary matrix. Let us now see efficient solution that requires same time theta n square but big O of 1 auxiliary space. If we take a closer look at this problem, we can notice that this problem belongs to the transpose problem. In transpose of a matrix, last column becomes the last row. Second last column becomes the second last row. Third last column, third last row. First column, first row. And here what we want is, we want last column to become the first row, second last column to become the second row. So if we have constructed transpose matrix, we can convert it into our required matrix by simply reversing the columns, by simply making the last row to first row, second last row to second row, and so on, right? So last row has to come at this position, second last row has to come at this position. It should become the second row, third last row should become the third row, first row should become the last row. To do this, we need to simply reverse individual columns and we get our required result. So we need 2 steps. First, we need to convert the matrix to its transpose, and once you have the transpose, you need to reverse individual columns. We have already talked about an in-place algorithm for transpose computation or transpose conversion, which is in place. Reversing column is easy. You just need to reverse individual columns. Now please pause this video and try to implement this approach yourself. Let's now see the implementation of efficient approach. So here we have written the code. First thing that we are doing is finding the transpose. We have discussed transpose finding in detail in the transpose video. Let's do a quick recap of the transpose step. So this is our input matrix. Transpose is going to convert this matrix into this matrix. Your first row becomes first column, second row becomes second column, and so on. To find the transpose, we know that diagonal elements are not going to be changed. They are going to remain as it is. And these upper triangular elements need to be swapped with the lower triangular elements. This 2 should be swapped with 5. This 3 should be swapped with 9, 4 with 13, and so on. So we run a loop that goes through every row one by one, and for every row I, it goes to the column number from I plus 1 to end and simply swaps array ij with array ji, right? That's what it does. Then goes to the next row, swaps the elements from I plus 1 to n minus 1 with corresponding elements in the lower triangle, right? And so on, 12 with 15. So that's how we find the transpose of a matrix, and this transpose algorithm is in place. It does not require any auxiliary matrix, and it works in theta n square time. Once we have found the transpose, our task is to simply reverse the transpose matrix. And after you reverse individual columns, so when we say reverse, we mean reverse individual columns. So once we reverse individual columns, we get this matrix, and that is our target matrix, right? So in the rotate by 90-degree problem, we wanted last column to become the first row. And what transpose matrix does, it makes the last column as last row, second last column as second last row, and so on. To get the actual effect, we simply reverse individual columns so that the last row becomes the first row and first row becomes the last row. So we reverse this column, we get 4, 3, 2, 1. We reverse this column, we get 8, 7, 6, 5. We reverse this column and then this column. To reverse individual columns, we have simple logic. We are traversing through every row. For every row, we are using simple array reversal algorithm. We initialize a low variable as 0 and high variable as n minus 1. We run a loop while low is smaller than high. We simply swap matrix low I with matrix high I. Column number remains the same, it's I, but low and high row numbers are simply changed and they are swapped. After that, we do low plus plus and high minus minus. So this is how we reverse individual columns. So this algorithm rotates a matrix 90-degree anti-clockwise, and it does this rotation in place and requires theta n square time.